Welcome back. And in this video lecture, we want to talk about arrays. Arrays, like variables we've dealt with, are very much like that. The only difference is an array is a group of values. Here, I've got two arrays. The first array is called A, and the second is B. Part of the way that you know it's an array is it's got a set of square brackets here. The 5 inside says it's an array of 5 elements, all of type int, meaning they're all integers. They could be float or other types as well. Here, we use curly braces to initialize the array. That means we know all the values are. Here is an uninitialized array, where we've said it's also 5. We want to do different operations with arrays. One of the basic things would be, say, to print out the array. Now, unfortunately, this won't work because there's no separate mechanism for printing out all the elements of an array. All we can do with a simple print statement is print out a single element. So perhaps we would want the fourth element. Let me just make that %2 and 4 times. Like that. And let's see what that will give us. Let's compile. See if we have any error messages. Okay. And now it's running. Let's look at the output. Hold on, that's interesting. I've asked for the fourth element, and it's actually only given me, it's given me 50, but that's the fifth element. And that's one of the first things that we have to be careful about when we deal with arrays. In C, you start counting from 0. So this has 5 elements, but this is element 0, this is element 2, element 3, element 4, element 5. So if I do 0 and 0 and compile this, you can see A0 is 10, what we expect. If I want to print them all out, or essentially do almost any operation with arrays, you need to have a for loop. So if I want to print out all of them, so for I equals 0, semicolon, I less than 5, semicolon, I plus plus, bracket, bracket, I. This is how I would have to do it. I think I've set this up right. Let's compile it and see what we get. I get an error message, error 1. Let's see where that is. There's something it doesn't like here. Let's try that again. That's interesting. Ah, right. I forgot to define I. Try this again. No problem. And you see here it's printed them all out. These are from the last run. Okay? So for loops are how we do everything. The same way if I wanted to do something with B. Suppose I wanted B to be 3 times A plus 2. I couldn't write it like that. I'd have to write something like this. Elements of B would be 3 times the corresponding element of A plus 2. And I'm going to just make this B and B. So stop this, go this, and I've got error number there again. Syntax. Yes, I forgot a semicolon. And we look at the output. 3 times 10 in 2 is 32, and that did all my calculations correct. So, arrays are shown by having these square brackets. We can initialize them if we use curly braces. If we want to work with arrays, essentially we have to use a for loop. The next little part of this video will look how we use arrays with functions. Now we want to look at how we pass an array to a function. Use arrays and functions. This array A might remind you of a vector. There's a one-to-one connection between those two. A 1D array is any kind of n-dimensional vector you want to talk about. And you might recall from your linear algebra courses that there's a quantity called the norm, or the RMS length of a vector. And let's write a function that calculates that. You might remember what you do is an n-dimensional Pythagorean theorem. So 10 squared plus 20 squared plus 30 squared plus 40 squared plus 50 squared square root gives you the length or norm of the vector. Now that that comes back is going to be a float, so F-L-O-A-T, and norm. And what we have to do is we have to tell it we want to use a vector. So it's an array of type integer, and to specify that you're sending an array, you just leave the square brackets blank in here. So if you left out the brackets, it would be an integer, but with the brackets it knows it's expecting an array. And the other thing you have to tell it is how big the array is, the array size. So that's the prototype we're going to work with. So let's take this and write that function. Okay, and so we're going to have to do a summation, and we need a for loop. Right, so for I equals 0, semicolon, I less than array size, semicolon, I plus plus, we are going to calculate our quantity. It's going to be, I should create it here first. Let's call it float norm value. So float typos right here. Norm value equals array bracket I times array bracket I. So we're squaring all the elements and adding it to the value of norm, or norm value. Okay. So we should start with this being equal to 0, so we don't have any problems. And when we're finished, we're going to return the square root of norm value. And since we're using square root, we need to include mathh library. Okay. So we've got the prototype, we've got the function, and here printf norm equals %f slash n slash r comma norm of a. Sorry, calling the function, so it's a comma 5. You notice here I'm not using the square brackets with a, because it's been defined as an array here. It knows I'm talking about this guy now. So let's see what we get. Compile it, look for some errors, build successfully, go to the output. Here we have, okay, so here we have the norm. We could check that out, but that's pretty well correct. Okay, so that's how we pass an array to the function. But what if we wanted a new function back? Well, return only returns a single variable, whether it's a float or an integer. So how do we put an array in and get an array out without it being a series of functions? Well, we can do that too. I'm going to create a new function, and what that new function does is it takes an array and it swaps the last term with the first, the second last with the second, and so on. We're just reversing the array. So I'm going to call it void reverse. And the way you would do that is there'd be an array going in, and you'd create space for an array coming out. And as previously, you have to say what the array size is. Okay, so let's take this function and actually write it. We have to do much the same thing that we've done before. This function that I'm creating is void because all the work is being done in my output array. So there's no return necessary. And what we want to say is array out. And we're going to go this backwards, so it's array size -1 minus I is going to equal array in I. Okay, so the way this would work, we have 5 elements, so we're going from 0 to 4. So 5 minus 1 minus 0. So the fourth term, we're going to be array in 0. And down until this one hits 0 and this one hits 4. That should work. I think I've got that right. Okay. And so up here, I'm going to call the function, and it's reverse A, and we're going to be sending it to B, and it's of size 5. And we're going to print those elements out again. I don't want this. This will give me my elements. Might as well get rid of this. We're not using this. And we'll compile. I'm going to clear the output first. Clear. Okay, now we're going to compile and run. Successful. Let's look at the output. And now you see B0 is 50, 40, 30, 20, 10. We've created a reversed array for B, just like we said we would. So, if you want an array out of a function, you have to make space for the array coming out. Okay? Again, in functions, this little square empty bracket says I'm sending in an array. This guy's void because there's no return here. The last thing we want to talk about when we're talking about arrays is you can have multi-dimensional arrays, just like you can have multi-dimensional matrices in your linear algebra courses. Okay, so what I've done here, I've defined a 2D array. Mostly 2D arrays are probably as big as we're going to go to, but you can have as many elements as you want. So this is a 2 rows and with 4 elements each. Now I've initialized it, and I've got brackets for all the 8 elements. And to make the grouping clearer, you can optionally put in brackets here and here. I recommend doing it. It makes it easier to read what the rows are. Now if I want to print them out, I've got to use nested for loops. So we're going to do the same thing. So I'm going to do for I equals 0 to 2. That's like that. And what we're going and inside here we need another loop. So we'll call that for j equals 0, semicolon j less than equal to 4, j plus plus, brackets. Okay. So I'm going to print out some things here. I'm going to print out all the elements to on the same row. So row and %u. That's going to be the I. Actually, I'm going to change this a bit. Make this do exactly what I want. %u. And I'm going to use a tab to move this across. And this is going to be CJ. Okay. C. Bracket I. J. And I don't need that J right here. I'm going to print F. Row %u /n/r. I'm going to do it with I. And this should happen twice. Actually, I don't want that n/r either. Right here, I want to tab. And when it finishes the first row, I want it to skip a line. I think this will look mostly the way I want it. And okay, so let's build it. Typos. Build it again. Okay, and let's look at our output. So row 0 has 5, 10, 15, 20. Row 1 has 3, 9, 27, and 81, just like we said. Okay. Again, you could pass this to a function, and if you're passing it to a function where we have a single set of square braces here, we would need 2 square braces. Okay. And if it was a 3D array or 4D array, again, the number of braces that you need.